Hey everyone, welcome back to my channel EduVibe. Today we start with another topic of the Unit B, which is grade 11 chemistry. We are doing the Charles law. So this law is the same like a Boyle's law, but they have a different definition and a different terms we use. So in the Charles law states that as the temperature gas increases, in the Boyle's law we take the temperature as constant and the chemical amount of gas is also constant. But in that case, we take temperature of gases when it increases, the volume of gases also increases proportionally. So, which provide that the now pressure and the chemical amount of gas remains constant. So now pressure and chemical amount is constant, and the volume and temperature is both increases. If temperature increases, so the volume is also increases. So both are directly proportional. Volume is directly proportional to the temperature now. So this is direct relationship. And if the gas did not liquefied absolute zero, the kinetic energy of all entities would theoretically become zero. Thus, they would have a zero volume. If the absolute zero of kinetic energy is there of the entities, so this means that we have a zero volume because they have a directly proportional, and we get this kind of graph, the straight line. But as the volume increases, temperature is also going to be increased, like the straight this line. So that's the inverse directly relationship of these both of them. So if this is directly proportional, so we have a different kind of equation we have. So this formula also have to be memorized by you. So we have V1 upon T1 is equal to V2 upon T2. So V1 is initial volume, V2 is the final volume, T1 is the initial temperature, and the T2 is the final temperature. So it stays the same, just you have to memorize this thing. So any units of the pressure may be used as long as they have the same units as I told you in the Boyle's law. But in temperature, you must be in the Kelvin. If you have in Celsius, you have given the temperature in Celsius, you have to convert this into Kelvin first. And to convert this into Kelvin, you have to do plus 273.5 of Celsius. Anything Celsius will give you in the Kelvin. So that just you have to do plus. If they mention that your answer that your temperature should be in Celsius at the end, so you have to leave this in Celsius. So let's move on to the example. So in the test of Charles' law, gas inside the cylinder with the movable piston is heated to 315 degrees Celsius. The initial volume of gas in the cylinder is 0.30 liter at 25 degrees Celsius. What will be the final volume when the temperature is this 315 degrees Celsius? So what they mention. So initially your volume is this, which is V1, and at temperature of this, so this is T1, and at that temperature, which is T2 now, what is your final volume? So you have to find the V2. So your formula is V1 upon T1 is equal to V2 upon T2. You have to find V2, do the cross multiplication, this goes over there, so V2 T1 is equal to V1 T2. You have to find V2, so V1 T2 upon T1. So now, but the temperature is in degrees Celsius, you have to convert this into Kelvin. So how you can convert? So T1 is equal to 21 degrees Celsius plus 273.15, you will get 298.15 Kelvin. 42315 degrees Celsius plus 273.15, you will get 588.15 Kelvin. So V1 is 3.030 liters, T2 is 588.15 Kelvin. Divide this by 298.15 Kelvin. So Kelvin cancel, and you get V2 in liters, which is about 0.5917 liters. You want in 3 say this with 0.59 liters. So this is your volume. So that's how you can find the volume of the when temperature is 315 degrees Celsius. This is the final volume. So that's how you can use this formula and make sure you have 2V plus this by temperature to be converted this in Kelvin. So you have to use Kelvin. And the pressure, all the pressure units are same. In next one, we have a next question. A balloon with a 8.50 liter of air inside at 30.0 liter shrinks to 4.50 liter. So if the first volume is this, it shrinks to this 4.50. So this is V2 and this is V1, and at temperature, so this is T1. What the temperature of the air inside the shrunken balloon in degrees Celsius? Now they mentioned that your answer should be in degree Celsius, and you have to find the T2. Basically, that T1 should first be, when we put this in the formula that V1 upon T1 is equal to V2 upon T2, when you put this thing, when you put this T1 into this formula, you have to in Kelvin. At the end, you have to again minus this by 273.15 to convert back into the Celsius. Okay, so we have 30.0 degrees Celsius plus 273.15, you will get 303.15 Kelvin. Now we have to find T2. So to find T2, you have T2 V1 upon V2 T1. So T2 is equal to V2 T1 upon V1. So V2 is 4.50 liters, T1 is 303.15 Kelvin, and your V1 is 8.50 liters. The liters cancel out. You get T2 about 160.49 Kelvin, but now you want this in Celsius. They mentioned this over there. So you have to minus this by 273.15. And when you do this, you get T2 about in minus 112.65 degrees Celsius. You in 3 set this, so it's minus 113 degrees Celsius. Now, temperature is in negative 2. Negative and positive temperature, you have both temperatures in negative and positive. So this should be negative. This must be negative. If you get the negative, so you can leave it like this. But when sometimes you have in pressure or in the volume, they must be in positive. So you have to take care of these things now. So you get this in Celsius as they're talking about. So that's how you can do all the work to get the temperature in Celsius. At the end, you have to minus that. First, you have to be in Kelvin to put this in formula. So that's the whole thing of the Charles law. That's all you have to know in this. The simple questions you get like Boyle's law and the combining volumes. In the next lesson, we could start with another law, which is combined gas law. We combine all things and then the law. So let me say I do vibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay carried with EduVibe.